The purpose of this video is to find the greatest common factor of a list of terms. So we're not adding or subtracting them together yet, we're just taking individual terms and looking at what's common amongst them. Okay, so in this first example we have 2x to the 8th, 4x to the 4th, and 12x cubed. Okay, so I'm going to look at the numbers first, and I look at 2, 4, and 12. Well, I know that 2 goes into 4 and it goes into 12 evenly, right? And nothing bigger than 2 goes into 2, right? So 2 is going to be our greatest common factor here. And then amongst the variables, we have x to the 8th, x to the 4th, and x cubed. Okay, so what do all of those variables have in common? Well, they have x cubed in common, right? So since there are 8 x's in the first term and 4 in the second and 3 in the third, we know there's at least 3 in each of them, right? So we're going to have 2x cubed as our GCF. The GCF is 2x cubed. Okay. All right. So let's go to this next one. We've got 15t squared, 10t, and 20. Okay, so let's just look at the numbers for a minute. And in each one of these I have a number. 15, 10, and 20, right, are the numbers. So when I look at those, the first thing I think, right off the bat, I think, well, they all have the factor of 5 in common, right? 5 divides 15, 10, and 20 evenly, okay? Is there anything bigger than 5? Well, 10 goes into 20, but it doesn't go into 15, right? There are certainly other smaller factors that go in here, but I think 5 is the greatest one, right? Okay, so we've got 5. Now look at the variables. So in the first term I have a t squared, in the second term I have a t, and in the last term I don't have any variable. Okay, so I can't say that t is common to all of them because it's only common to the first two terms, right? So the GCF is just 5 here. Okay. All right, now let's look at x squared, y squared, and 4. Okay, so only one of these terms is a number, right? Or has a number involved, and that's 4. And so we can't even really look at taking the GCF of the numbers because we don't have one in every case here. And also, the variables that we do have are different, right? We have x squared and then we have y squared. So there are no common factors here, right? So if this was a polynomial, we might say that it's not factorable or that it's prime. If you're looking for just the GCF of a set of expressions, so the greatest common factor here, the GCF, is 1, right? So if you just have a set of expressions and they don't have any common factors at all, they all have 1 in common. If this was a polynomial, though, that we were wanting to factor, we would say that it's not factorable or it's prime. So let's go down here. We've got x to the 4th, y cubed, x squared, y squared, and xy to the 5th. Okay, so each one of these terms contains a certain amount of x's and y's, right? Okay, and if you want to write them all out and see what's common about it, that's fine. But remember what I was saying about thinking about what is the largest amount of each variable that you know exists in everything. Okay, so like in the first one, we have x to the 4th, right? And in the second one, we have x squared. And in the third one, we just have x. Okay, so we know that x, because of that last term, x is common to all of them, right? The first term has 4 of them and the second term has 2 of them, but since the last term only has 1 of them, we can only have one of them in the greatest common factor, right? And then look at the y's. So we've got y cubed, y squared, and y to the 5th. Okay, so each one of them has at least 2 y's, right? Because the second one has that lowest power, which is the 2, right? So if there's y squared as a factor in the second term, and we have 3 of them in the first and 5 of them in the last, then we can say that y squared will divide all of those evenly. Okay, so the GCF here is xy squared. Okay. All right, now this last one, a little more complicated. It has numbers and two different variables. So we have 24a squared b squared, 32a cubed b squared, and 60a to the fourth b to the fourth. So when I look at a problem like this, I can certainly write out the prime factorizations and find it, and I will do that with you in a moment so that you can see that. But I also want you to get good at just thinking about this, okay? So if we've got 24, 32, and 60, um, I think about the largest numbers that I know to divide these in the times table, right? So like 12 goes into 24 and it goes into 60, but it doesn't go into 32. So that we can't use. I also notice 8 goes into 24, it goes into 32, but it doesn't go into 60. Now 4 is a good candidate, right? Because 4 goes into 24 4 times, it goes into 32 8 times. And let's see, 60 divided by 4 is 15, right? So 4 is probably where we're at. Okay, but let's look at the prime factorizations for a moment. All right, so let's just do a little tree. So over here with 24, we've got 2 times 12, then 2 times 6, and 2 times 3. Okay, so we've got a prime factorization of 2 cubed times 3, right? And then with 32, let's do the factorization there. So we've got 2 times 16, which is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Okay, so 1, 2, 3, 4, 5. 2 to the fifth, right? And then 60, we've got 2 times 30. 30 is 2 times 15. 15 is 3 times 5. Okay, so we're going to have 2 squared times 3 times 5. Okay, so when you're looking at the GCF of all of those, all of them contain a 2, right? And the lowest number of times it occurs in any one of these is in the last one in 60, which is 2 squared, okay? So that's the 4 that we came up with last time, right? 24 and 60 have a factor of 3, but 32 does not, right? And then 60 has a factor of 5 as well. So 2 squared is all we've got. Okay, so we've got 4. Okay, now in the same way we're looking at those variables, right? The lowest number of times we see it in any given term. So in the first one we have 2 a's, right? A squared. The second one we have a cubed, and in the third one we have a to the fourth. Okay, so I know that I've got at least an a squared in each one of those, right? And then, so now let's look at b squared. We've got b squared, and b to the fourth. Okay, so we've got at least a b squared, right, in all of those. All right, so the GCF is 4a squared b squared.